Hello friends, welcome to this video by Gild Academy. Today we are going to discuss the problem of Tower of Hanoi. So to begin with, let me give you a brief explanation of what this problem is all about. So as a part of this problem, we will be provided with three towers. A source tower labeled as A, a destination tower labeled as C, and an auxiliary tower labeled as B. Along with these three towers, we will also be provided with some number of rings with us. These rings are going to be of different shapes and initially they will be placed in the tower A in increasing order of their shapes. As a part of the solution of the problem, we need to move all these rings from tower A one at a time to tower C. And in order to do so, we can take help from the tower B, the auxiliary tower. So we may move a ring from tower A to tower B and from tower B to tower C, something of this sort. But there is a very important condition to be met. And the condition is that there shouldn't be a situation when a bigger ring is on top of a smaller ring. So what you can see on the screen right now is not allowed. Going forward, we will be referring to this condition as the condition of Tower of Hanoi. Let's do a quick run of the solution of this problem for three rings. So as you can see, we can we have three rings of different shapes arranged in increasing order of the shapes in Tower A, and with the help of Tower B, we need to move all these rings from Tower A to Tower C. So the way we can solve this problem is we may move the ring from tower A to tower C and then we move the ring from tower A to tower B. Following this, we may move the ring from tower C to tower B. Now, since the largest ring is available in tower A and this ring also has to be right at the bottom in tower C as well, we directly move this ring from tower A to tower C. Then, in order to keep the condition of Tower of Hanoi intact, we move the ring from tower B to tower A. Then we move the ring from tower B to tower C, and finally we move the ring from tower A to tower C. As you can see, we just now solved the problem of Tower of Hanoi for three rings. But there could be any number of rings. There could be a single ring, there could be two rings, there could be four rings, there could be hundreds of rings. The number of rings will be an input to us, and our solution should provide us with instructions as you can see in the right side of the screen. The instructions following which should help us to solve the problem of Tower of Hanoi for the number of rings which was an input. So at this point, I would really encourage you guys to pause the video for a while and try to solve this problem for say 4 rings. Following which, you may come back to this video and see how exactly we are making an approach to solve this problem. Hello friends, now let's try to solve this problem. So the way we are going to solve this problem is we first will begin with the most basic problem statement that this problem of Tower of Hanoi can have. After solving this problem, we'll list down the observations that we can make. Then we'll move on to the next most basic problem statement for this problem and again list down the observations. We'll try to figure out some sort of a pattern amongst these solutions and then formulate a generalized solution for the problem of Tower of Hanoi. So let's begin. The most basic problem statement for the problem of Tower of Hanoi would be when n equals 1, that is we have only one ring. The answer is pretty simple. We just move the ring from tower A to tower C. So let's have a note of what are the observations that we can make. And the observations are the maximum number of rings that the auxiliary tower or tower B ever had during the course of the solution was 0. And when the source tower has only one ring and the destination tower is empty, we can directly move the ring from the source tower to the destination tower. That is, we move the ring from tower A to tower C. The next most basic problem statement for the problem of Tower of Hanoi would be when n equals 2. That is, we have two rings in the source tower. The way we can solve this is we move the ring from tower A to tower B and then move the ring from tower A to tower C. Finally, we move the ring from tower B to tower C. Let's have a look at the observations that we can make out from this particular solution. And the observations are the maximum number of rings that the tower B ever had during the course of the solution is 1. But very importantly, we first moved the smaller ring from tower A to tower B. That is, we moved the smaller ring from the source tower to the auxiliary tower. And for this particular movement, we treated C as the auxiliary tower. Although we didn't use that tower for any sort of a movement activity, but we can say that since for this particular movement, the source tower was A and the destination tower was B, we treated C as an auxiliary tower. Now, since the tower C was empty and we had the largest ring available for movement in tower A, we moved that ring directly from tower A to tower C, and then we moved the smaller ring, which was in tower B right now, to tower C, and we can say that we treated tower A as the auxiliary tower during this time. Now, things will be clear even more when we try to solve a slightly more complex problem, and that would be when n equals 3. Since we had already seen the solution for this problem earlier, I'll quickly browse through the solution, and that would be we move a ring from tower A to tower C, and then move the ring from tower A to tower B, and we move the ring from tower C to tower B. Now, since the largest ring is available in tower A and the tower C is empty, I move the ring directly from tower A to tower C. Now, in order to keep the condition for Tower of Hanoi intact, we move the ring from tower B to tower A, and then move the ring from tower B to tower C, and finally move the ring from tower A to tower C to solve this problem. Now let's have a look at the observations, and the observations are the maximum number of rings that the tower B ever had is 2 in this case. We first moved the two smaller rings from tower A to tower B, treating C as the auxiliary tower. So as you can see, the first three instructions in the solution, we actually moved the two rings from tower A to tower B, and we had treated tower C as an auxiliary tower in this case. Finally, since we found that this tower C is empty and tower A had the largest ring available in it, we directly moved the ring from tower A to tower C, following which we moved the two smaller rings from tower B to tower C, and you make and we made use of the tower A as the auxiliary tower. Let's have a closer look to the point 2 and point 4. At point 2, we said that we moved the two smaller rings from tower A to tower B, treating C as the auxiliary tower. So this is nothing but the solution to the problem of Tower of Hanoi with two rings. It's just that we treated tower A as a source tower, we treated tower B as a destination tower, and we treated tower C as an auxiliary tower. And in the fourth point, we said we moved the two smaller rings from tower B to tower C, treating the tower A as the auxiliary tower. So this is again nothing but the solution to the problem of Tower of Hanoi with two rings, but again we treated tower B as a source tower this time, we treated tower C as the destination tower this time, and we treated A as an auxiliary tower this time. So as we can see, the problem of Tower of Hanoi for three rings was solved by making use of the solution for the problem of Tower of Hanoi with two rings. So let's imagine that we have a procedure called Tower of Hanoi which takes four, four arguments, which has four arguments, and the four arguments are the first one is the number of rings, and the next three are the labels of the source, auxiliary, and the destination tower. So the three the procedure called for the problem with three rings would be like this. That is, we have three rings to be moved from tower A using B as an auxiliary tower to tower C. So based on our earlier observations, we can see that this problem got solved by somewhat like this. That is, in order to solve the problem of Tower of Hanoi for three rings, we had to first solve the problem of Tower of Hanoi for two rings, but we treated A as the source, B as the destination, and C as the auxiliary tower. After solving the problem of Tower of Hanoi for two rings with A as source and B as destination, we had an empty C ring and empty C tower and only one ring in tower A. So we directly moved that ring from tower A to tower C, and then we again solved the problem of Tower of Hanoi for two rings, and this time we moved the rings from tower B to tower C using A as the auxiliary tower. Now we can see that there is some sort of a recursive call happening over here. So the Tower of Hanoi problem for two rings would look somewhat like this. So the first Tower of Hanoi for two rings would look like this, and the second procedure call for the Tower of Hanoi problem with two rings would look somewhat like this. As we can clearly see, there is some sort of a pattern. in the solutions that we have in front of us. If we generalize these solutions, then we can derive that the problem of Tower of Hanoi can be solved by this type of a procedure call. That is, in order to move a ring n rings, in order to move n rings from tower A to tower C using B as auxiliary tower, all we need to do is move n minus 1 rings from A to B first using C as auxiliary, then move the larger one from A to C, that is the source to destination, and finally we move the n minus 1 smaller rings which are in B right now to C using A as an auxiliary tower. At this point of time, I would really leave you guys to have a look at the solution and try to absorb the solution as much. After this, I will be quickly showing you a demonstration of this solution with a Java code. So till then, have a closer look at the solution. So friends, let's quickly implement the solution to the problem of Tower of Hanoi. So I'll create a new class and name it as move rings, and let me have a method named as Tower of Hanoi. And as we have seen earlier in our pseudocode, we will take number of rings as an input and the labels of the source tower, the auxiliary tower, and the destination tower. So all we have to do is that in order to move n rings from source to destination using an auxiliary tower, we have to first move the n minus 1 rings from the source to auxiliary tower using the destination tower as the auxiliary tower over here. And then we simply move the largest string which is available in the source tower to the destination tower, and then move the n minus 1 rings from which are currently in the auxiliary tower to the destination tower using the source as the new auxiliary tower. So this is the exact implementation of the pseudocode which we had seen earlier. But since this is a recursive call, we definitely need to have a boundary condition, and we can have a very simple boundary condition saying that if n equals to 0, do nothing and simply return. So this is our implementation for the Tower of Hanoi procedure. So we can have a method call and have a variable representing the number of rings, and we can have the source as A, auxiliary as B, the destination as C. So let's see what would be the solution of this problem when we have only one ring. And as we can see, it correctly tells us that you can directly move the ring from A to C. Now let's see the solution for two rings. And as it again correctly says that we first move the ring from A to B, and then we move the larger ring from A to C, and then the smaller ring from B to C. And then the problem of Tower of Hanoi for two rings is solved. Let's also see for three again. And the way it would be is we first move the first two rings to the auxiliary ring. So the first three instructions tell us exactly to do that. We move the first ring from A to C, then A to B, and then C to B. Then the larger ring that is available in tower A has to be moved to the tower C, and then the leftover smaller rings from tower B to tower C. So these solutions tally with the solution which we had seen earlier. Now let's find the solution for Tower of Hanoi with for four rings. And it seems that we have quite a lot of instructions, and let's see whether these instructions hold good or not. So as you can see that we have four rings of different shapes arranged in increasing order of their sizes in tower A. So the way we can solve this is we first move a ring from A to B, and then move a ring from A to C, and then move the ring from B to C. Then we move the second largest ring which is available in tower A to B. Then we move the ring from C to A, move the ring from C to B, and then move the ring from A to B. As we can see, we just moved n minus 1, that is 3 rings from A to B using C as the auxiliary tower. Then the largest ring is available in tower A and the tower C is empty. So we move the ring directly from tower A to tower C, and now we can move the three rings from tower B to tower C using A as the auxiliary tower. So this is same as the solution to the problem of Tower of Hanoi for three rings. And the way we are going to solve this is we move the ring from B to C, move the ring from B to A, and then move a ring from C to A. Then we move the ring from B to C, and from here it's pretty much straightforward. A source tower being A and the destination tower being C. We have to move the smaller ring from A to B, then the ring from A to C, and finally the ring from tower A to C. So it seems as a solution which we got with our procedure implementation for n equals to 4 seems to be working fine. And this is how we can solve the problem of Tower of Hanoi for any number of rings. With this, we conclude our discussion for the Tower of Hanoi problem. I hope that you really like this video. I would really like to encourage you guys to subscribe with Gild Academy for many more videos that would be coming pretty soon. Happy coding!